Good afternoon, everybody. Hopefully you can hear me again, and hopefully you managed to get a bit of a break at lunchtime and are refreshed and ready to go for this afternoon. I see we've got most people back for the afternoon session, so I'll go ahead and get started. So this afternoon, we're going to try and put into practice some of the bits and pieces, or use some of the concept, use some of the information we learned about ARCHER2 in the morning to work and run some jobs, and try and get to know the schedule a bit. That's I guess the meat of the sort of practical stuff, and then we'll talk a bit about being a good citizen on the system, and making sure the systems, the systems, most the people users on the system can get the most out of it, as we all behave well on the system. Finally, later on in the afternoon, we've just got a session on a brief session on SAFE and what sorts of information you can get out of SAFE on your usage of the service and administering your account and that sort of stuff. And then a very short section on where to go next after this. After this training, and where you can get more help and what your options are going forwards in terms of either further training or learning more about the system, or getting to use the system, or even applying for access if you don't already have a route to getting an account long term on the system. So, but first, before we start that, we're going to have a look at the scheduler. As I said at the start, we're not going to talk about what a scheduler is and how why they're used on HPC systems, but we're going to look more at the practical information about how you use the Slurm scheduler on ARCHER2, and the options and the configuration that are particular to ARCHER2 that may differ from some other HPC systems that have used, because Slurm's quite widely used across different HPC systems. So to start off with, we're going to get ourselves logged back in to the service, because we're going to be typing commands and actually doing stuff during this session. So I'm going to get myself logged in. If I can type my password correctly, I might have got it wrong. Oh no, there we go, got it right that time. And as we discussed, or as we talked about this morning, when we're running jobs and working with the scheduler, then we need to be running on the work file system. As an illustration, I'm going to start doing stuff on the home file system, and you'll see what the errors that pop up when I start doing stuff, or start trying to actually submit jobs. So that'll give you an idea that hopefully it'll ring a bell. Oh, sorry. Yeah. I am obviously not very switched on. I had too much of a break during the lunch break, and forgot to share my screen. Give me a second. Thank you for pointing that out. Sorry for the omission. There we go. Sorry, I hadn't actually done anything very much. I just accessed the section on the Slurm, and I had logged into the system. So that's all I've actually done. So you didn't miss anything. Didn't miss anything too exciting. Thank you for pointing that out for me. Right, let's try that again once more with feeling this time. So I'm logged into the system, and you can see I'm in my home directory on the home file system at the moment. So let's start off with, we're going to look at the command to find out. There's various commands in Slurm. The first one we're going to look at is sinfo, which tells you about what resources are available on the system, what's being used, how much is available at the moment, and what the different nodes look like. So if you just type sinfo without any argument, it gives you a summary of what the system looks like. So sinfo, you type, it gives you a summary of the system. So it consists of a number of different columns here. There's a partition column on ARCHER2 at the moment. There's only one the one partition, which is standard. So there's only ever going to be one partition listed there, and because there's only one partition, all of the availability settings will be the same, and the same for the time limit. But then it tells you which nodes are in all these different states, and there are various states that nodes can be in. And typically, nodes that are available or are running jobs are in one or two states. They're either in alloc or idle. Alloc means this list of node IDs. Remember, there's 1,024 nodes on ARCHER2. These 954 nodes are allocated to jobs and are running work at the moment. At the moment, there's only 3 idle nodes out of the ones that are up. Okay, so at the moment there's 957 nodes generally available. 954 of them are used, 3 of them are idle. So you may or may not be able to run a 1, 2, or 3 node job at the moment. It depends how long those nodes are going to be idle for, when the scheduler thinks they're going to be needed for other jobs in the queue, whether you could actually jump in and use them right now. And that's the scheduler's job, is to try and manage this packing problem as efficiently as possible. There are 40 nodes reserved. Some of those are in the reservation for this course, and some of them are probably in other reservations. So those ones, while are ready and able to do work, are not generally available to normal users on the system, because they're only available to people who have access to the reservations. The 4 nodes that are down are just either broken or unavailable for some reason. These ones that are marked drain or drain star are nodes that are in the process of draining of jobs because they need some maintenance done on them. So the system administrator said, I need to do some work on that node. When that job has finished, the current job's running on finished on it, don't put it back in the main pool, just leave it down, so I can go and do something to it. They're many of they're the most common states that you'll see as time goes on. There are some other ones. There's a fail state, and there's a maintenance state as well. You might occasionally see the maintenance one if ARCHER2 has a maintenance session coming up. Nodes get put into the maintenance state so that they can't be used, so that user jobs, node user jobs are running when they switch the machine off, set for maintenance. Excuse me. And fail is for nodes that have failed in some sort of sanity check and have been marked that there's something wrong with them, that somebody needs to go and look at them and check them out. That's the summary view. SInfo does take other options. So in particular, you can give it the -n option, which tells it to list individually each of the nodes. So it'll give a line per node. Because there's 1,024 nodes, you'll get a lot of lines. It doesn't show you very much when you do SInfo -n. It just tells you the node ID, which partition it's part of, and whether it's allocated and what its status is at the moment, in the same set of statuses. But you can also add the -l option for long, and that gives you a bit more info about the nodes as well. I wonder if I can make this window just a little bit wider, so we can see. And what I'll do is I'll pipe it into less as well, so I can actually see it before it scrolls past. And you can see what this time it's showing you is which node, the state, number of CPUs. This is a specification of what the layout of cores on the node looks like. So sockets, cores per socket, and threads per core, amount of memory, and various other bits and pieces as well. But that produces a lot of output because there's 1,024 lines. On the full system, when that arrives, it's going to produce even more output because there's going to be over 5,500 nodes. So you'll see a lot of information go scrolling past when you run that command. So we can use SInfo to find out particular information. If you look on the man page for SInfo, it has this -o option, which allows you to specify different properties of a node that you might want to look at. So let's have a look at a particular node. I'm going to take this command. I'm going to paste it into my terminal. So this is looking at a particular node ID, node number 1000, and it has this output specifier. And what this one does is it gives send to enemy and show me the name. %C is number of CPUs on the node, and %M is the amount of memory on the node. Okay, so it gives me the name, number of CPUs is 256, and the amount of memory is 256,000. Okay, so it's giving some. You can specify what information you want to get out of nodes, and if you want to know what all of the different codes are, you use man syinfo to get the manual page. Somewhere down here, it will tell you what the output format is. There you go. So here's the list of all the different codes that you can give to that to customize what you want to see. Generally, just info is the most useful command on its own, giving you some sort of summary of the state. But if you wanted to know what the architecture of the nodes was in a bit more detail, and what different architectures are available on the system, ARCHER2 at the moment is very homogeneous, so every node's the same. But there will be high memory nodes in the future, and potentially and the GPU nodes and various other bits and pieces. So at some point it will get more heterogeneous. Now, one thing you might have noticed when we ran this sysinfo command here, and you could change the node ID if you want and have a look at different nodes. You should find hopefully that they're all pretty much the same. One thing that you may have noticed, which seems a little odd, is the number of CPUs is 256. And if you remember back to this morning, one of the things I said when I was talking about the hardware was I said each node had two 64-core processors, giving 128 cores or CPUs per node. So why does Slurm think there's 256 CPUs available on each node? Well, that's due to something you may or may not have come across. So there's a concept of hardware threads where each physical CPU or core can appear as multiple cores. Okay, and that's in the olden days, I guess, and maybe still a bit. It was known as symmetrical multi-threading, or SMT. More recently, because the landscape was dominated by Intel processors, and they were often known as hyperthreads, which is the Intel terminology for SMT. I mean, technically, they aren't hyperthreads because these are AMD processors, and hyperthreads an Intel concept. But in reality, if people say hyperthreads, they know what you mean. But they are hardware threads, and this is what's meant by. Remember, we had this long listing here, and I said this showed this colon bit showed this breakdown of the architecture. So this says 2 sockets, 64 physical CPUs per socket, and 2 logical CPUs per physical CPU, or 2 hardware threads per physical CPU. So that's where the 256 comes from, because it's 2 times 64 times 2. Now, hardware threads are really useful in general for servers, which these processors are designed for. You know, say you go to Amazon Web Services, Azure, Google Cloud, whatever. They all use these. They all use these server class parts, and threading there is used to increase the concurrency performance of these things. So, say you're serving a website, you know, having 256 cores doing it instead of 128 makes sense, and there's no penalty generally, because often your core is waiting on something, either a response from the network or a response from memory or something like that. So you can switch in another thread very quickly to fill that time that you spend waiting and increase the efficiency of your processor. Now, on an HPC system, generally we're trying to design codes as efficiently, or run codes as efficiently as possible, to minimize that waiting. So what happens there is there's less spaces, so you tend not to get much value from using these hardware threads. So typically people only use the physical cores on a system that's 128. There are some cases where you can get some benefit out of using the extra hardware threads. The places I've seen it before in my experience is when you're using, for example, molecular dynamics simulations. So something like GROMACS or LAMPS or something like that can sometimes, depending on the case, depending on the size of the calculation and how it's distributed, get a little bit more performance by using hyperthreads, usually on the order of 5 or 10% more performance out of the node. So if you're using those sort of things, those sort of codes, or even if you're using a different code, you can experiment with this by specifying 256 cores per node on ARCHER2, and that will make use of the hyperthreads. on the system if you set it up correctly. I don't have an example job script in this course for doing that because it's generally not something what people want to do because it actually makes your performance worse, not better. But if people are interested in exploring it, let me know, and we can look at an example job script that can do that sort of thing. Sorry, let me get rid of my email clients because it's going to keep popping up things like that. That's really annoying. Let's get rid of that. Okay, so there are really 256 hardware threads available, but there are only 228 physical cores. But some people want to use them, so they're configured in Slurm for people to use if they want to. Okay. Right. So that's how we find out what information, and you can see the system's quite busy at the moment. You know, there's a lot of work running on it. Most of the nodes are in use. What about actually submitting a job to the system? How do we go about doing that and writing our job submission scripts? Okay, so you've probably on other HPC systems you've come across. I don't know if you used Slurm before, or whether you use something like PBS or even Grid Engine or any other scheduler. Most of them work in the same sort of way. Your job script consists of 3 bits, essentially, maybe 4 bits if you want to. There's the bit at the top which specifies which shell the script is in. There's this header section where you specify the options to the batch system itself, like the breakdown of how many nodes you want, how long you want to run for, which account to charge it to, all those sort of things. Then there's the bit which is just commands to run. They're the 3 bits. If you want to consider it 4 bits, there's usually a parallel launch command too. So there's sort of general setup commands for your job script, and then finally the launch command, which actually starts your calculation running. Okay, so we're going to have a look at running this XT-High program, which you saw in the list of modules when we were looking back at the software. XT-High is a useful little tool that what it does is it prints out when you launch the job which nodes, processes, and threads are running on. So it allows you to check that you've got the right distribution of MPI processes and OpenMP threads to processors. So it's a useful tool to put in before you actually run your calculation to check you've got the right placement before you go. But in this case, it's going to serve us as a simple way to run a job with some output that we can check. So we've got the first bit, which is the SBatch section, which these provide options to the job submission command. In Slurm, the job submission command for batch jobs, those where you submit a script and you can go away and come back and get the results later, is called SBatch. So these extra options are called #SBatch. And the various things we have here, these could also be specified on the command line to SBatch if we wanted, but it's more convenient in the job submission script rather than typing up those things out on the command line. We've got a job name. It seems pretty self-explanatory. That's the name of the job as it appears in the queue. We ask for a number of nodes. On ARCHER2, because of the way that the system's set up and because of its use case it's designed for, the minimum unit you can request on the system is 1 whole node. So you can the smallest unit you can request is 128 cores. You can then use those cores however you like. Say you wanted to run 128 copies of a serial program, you could do that, but you can't request a single core on a single node. You have to, in the minimum, even if your job only uses 1 core on a node, you'll be charged for all 128 cores because nobody else can use them while you've got access to them, because you get exclusive access to that node. You say how many tasks you want per node. This is how many processes, essentially, usually MPI processes you want per node. Often that's 128, but we'll see some cases in a moment where it's not. And the number of CPUs you want to use per task. This is essentially a stride between each task. For a fully populated node where you're using every core for a process, or an MPI process, these are 128 and 1. So there's 128 and you step 1 each time for the next task. You specify the amount of time, the maximum wall time that the job can run for. This is 10 minutes. Here, at the end of 10 minutes, whether your job is finished or not, it'll be killed by the job submission system and stopped. The account to charge the project to, in our case, this is TA035 because that's the name of our project. And then the partition and the quality of service for that too. So if you're not used to Slurm concepts, this can seem a bit confusing, but Partitions are groups of resource that are homogeneous. Now, there's only one partition on ARCHER2 at the moment because the resource is very homogeneous. Every node is exactly the same. So this is always going to be standard at the moment. In the future, when we have high memory nodes, there may also be, for example, a high memory partition, which contains the nodes with double the amount of memory. Okay, or there might be a GPU partition for nodes that have GPU cards on them, for example, you might see on other systems. And then the QoS is the thing that applies the limits. So like how many jobs can you submit? What the maximum runtime is? How many nodes can you request? Now, there are a few different QoSs. You can think of them almost as queues. I know it's not quite the same. It's not quite the same strictly within Slurm, but it is similar in concept because they set those things, set those sort of things. So let me have show you that there's quite a few QoSs in the documentation that are listed. So there's running jobs on ARCHER2, and somewhere there is quality of services. There we go. Okay, so you can see here in the list at the moment there are 5 different QoS. It's not quite there. There is another one as well. It's not listed here, but let's not worry about that. So there's the standard QoS, and in the standard QoS you can have a maximum of 256 nodes per job. You can run for a maximum of 24 hours. You can have a maximum of 64 jobs queued and a maximum of 16 running at any one time. But there's also another limit that there can only be a maximum of 256 nodes in use by any one user at any one time. So although you could submit, you could potentially have 16 jobs running. If each of those jobs was 256 nodes, you could only actually have one of them running at any one time because you hit this limit of the maximum nodes use. There's a short QoS, which is used for testing purposes, which can only support up to 8 nodes for up to 20 minutes. But generally, gives you very fast turnaround time, so you can, test scripts and test jobs before you submit them in earnest. There's a long QoS, which allows you smaller jobs, but for longer, so up to 48 hours. And then for people who want to run very large jobs, essentially up to the maximum size of the system. It says 940 here, but in reality, this is as many nodes as are up on the system. So you can run for a maximum of 3 hours, but you can submit a job up to the full size of the system. Okay, the minimum job size is 257 nodes. That's because anything less than that just falls in the standard QoS. And then finally, we have a low priority QoS, which only allows for short runtime. Other limits are pretty similar to the standard QoS. And it's uncharged, it's free, but anything that's in any of the other QoSs takes priority over it. So if there's something in one of the other QoSs waiting in the queue, then they'll run before the low priority one runs. Okay, so it's essentially a way to try out things or use things when the system's quiet, when there's not enough work to be running otherwise. So there are various QoSs, or queues as you can think of, that set these limits. Okay. The one we had in our in here was standard and standard, because the other one that this job could run in would be the short QoS, and it'd run very quickly there. Excuse me, but we wanted to show you a more standard job submission script first, and we'll show you it submitting to the reservation. So after we've set all our options here, then we do all our script stuff. I mentioned earlier that if you load modules, and if you want to use modules, then you have to load them in your job submission script as well. You can't rely on loading them on the login node and then submitting your job and that environment persisting into the job script. So you have to do everything in your job script. There's this special module that needs to be loaded in all job scripts to make sure that the environment's set up correctly on the compute node for you to be able to use it properly. Just take this as for the moment as something that just needs to be added in. It sets some environment variables and bits and pieces like that. To make XT-High available, we need to load the XT-High module, and that makes the executable available for us. We only want to use one thread per MPI process. Okay, so this is a pure MPI job, it's not hybrid MPI plus OpenMP. And then finally, we use the S1 command to do power run. So if you used, when you've used previous HPC systems, you may have used a command such as MPI run or MPI exec, or if you've used another Cray system, you may have seen something like AP run to launch a parallel executable. On ARCHER2, it uses it natively in Slurm, which is the S1 command. and then we give the srun command and the name of the program we're launching. These two extra options here, the hint no multi-thread, we just discussed why there were 256 nodes and hardware threads. This tells srun not to use those additional hardware threads. It says there's no multi-threading, so don't use the extra hardware threads, only use the physical cores. And the distribution block just tells it how to place MPI processes across the cores on the node so that it's most efficient for communications. Okay, so it just, what this actually says is place them sequentially on cores. So so process 0 on core 0, process 1 on core 1, process 2 on core 2, and so on and so forth. So let me take this job submission script. I'm going to create it, or I'm going to create a file on ARCHER2 itself, and then submit it using the sbatch command. So I'm going to call it testjob.slurm. I'll specify it here. So you can use whatever editor you like, whatever editor you prefer. I'm a VI user, just because I learned HPC a long time ago, and VI was what was available then. So I'm going to paste in the options like that. Sorry, paste in the job submission script like that. So a script that we've also got. There's also Emacs available in Nano if you prefer those editors as well. And everything should be right. The account's right. Everything else is right. I've called it my MPI job. Let's try that. So I'm going to save that file. So there's my file there. Okay. And the command to put a job into the queue on ARCHER2 is sbatch. Okay, and you submit. You may have seen other commands similar for PBS as qsub, for example. You may have seen before. The only additional thing we're going to do is, because we're on the course, we're going to use this special reservation that means that our jobs run as soon as possible and don't wait in the queue with all the standard jobs. I'm going to add that one on the command line rather than encode it into the script. You can always mix command line options and options in the job script. Okay. If you specify an option in the job script and then specify the same option with a different value on the command line takes precedence. You know, so if you usually run your job, for example, the standard QoS, but for this run only you want to use the short QoS, you could do that. You can keep your job script the same, and you just specify QoS on the command line, then that'll take precedence over the value that's been set in the job script. Okay, so you could selectively overwrite options in that way in Slam. But we're going to use this. We're going to use this sbatch command with this reservation TO035196, and my script is indeed called testjob.slurm, so I can just copy and paste that command hopefully into there. Sorry, I'm very lazy and I get bored of typing, so I tend to use copy and paste quite a lot. So let me try submitting that and see what happens. Okay, so this is the error you get from the submission system if you're trying to submit from home rather than work. And it gives you a warning. It's let you submit the job, but it gives you a warning that actually you've probably done something wrong, and you can cancel the job to get rid of it with the job ID. So I did that wrong, so because I should be on the work file system. So let me get rid of that just in case it's run. So I've got the job ID there, 470212. Okay. And I'm going to repeat this. I'm going to go to the work file system. So current working directory is that. So I'm going to cd/work. In fact, one of the things that can be useful on ARCHER2 is, rather than having to type work all the time, you could set up. This is a useful use of initialization files. So I can set an environment variable that always points when I log into this directory. So let me do that. So I could let me go back to my home directory. I'm going to edit my bashrc file, which is one of my init files, and I'm going to export work equals my work directory. Okay, so this sets the environment variable work to this value, and then I should be able to just it automatically gets sourced when you log in, but to save myself logging back out and in again, I can just source it now and then I should be able to CD $work, and it'll take me straight there because I've set the extract environment variable work to point to that location. So that's quite a useful thing to put in your bash RC file if you want. Right, and I need the job script here, so I'm going to copy from home. It was called test job, wasn't it? And then let's try submitting that again. Hopefully we'll get a warning this time. Oh, but actually I wanted the reservation, didn't I? So let's go back and find it. There it is. Okay, so this time it's submitted without the warning, so that's good. It thinks we're doing the right thing. And so our job's going to run straight away, hopefully. We've submitted it. If you want to look at the queue to see whether it's run or not, you can use the SQ command. That shows the current queue status. Now, it's going to have a lot of stuff in it because it shows everybody's jobs. And like you saw, the machine was very, very busy. So if you just want to see your jobs, you could do -u and then your username. I can never remember my username, so I can just use the environment variable $user. And it's showing that no jobs there, so my job must have finished. And in fact, it has. There's the output file there. Let me have a look in the output file. Okay, so it gives us some stuff about loading modules at the start, and then this bit here is the output from XT high. It tells you it was running across 2 nodes with these node IDs. Each node was using 128 cores per node, 128 MPI processes per node, and there's 1 OpenMP thread per MPI process. And you know, on node 0, rank 0, thread 0's affinity was to core 0. And you should see that that should go all the way up to 127 because the counting starts at 0, and then it switches to node 1, and the next 127 are on the next node up. Okay, so that's all working as it should be. Okay, so there's a little chance for you to have play around and try and understand some things. So can you work out what the default values are for SBatch options? You know, so if you didn't specify them, what would you get? You know, so if you didn't specify the budget or account that the job's charged to, what would you have? What would you get? If you didn't specify the number of tasks per node, if you didn't specify the number of nodes in your job submission script, have a go at that. The last form wall time as well is really hard. So, yeah, I mean, if you can manage it, if you know how to do it, that's great. If you don't worry about it. We'll look at it in a minute. So, it's 2:20 at the moment. So how about we'll give you 10 minutes, that's till 2:30, to have a go at this exercise and see if you can play around with job submission scripts to try and work out what the defaults are. Yes, so Zora's asking, should we always use the minus reservation option? Yes, always use the minus reservation. That just means your jobs run straight away. If you leave it out, nothing goes wrong, but it just means you might wait a long time for your jobs to run because the machine's busy at the moment. So it's just to give you, to allow you to jump the queue, essentially, because you're on the course today. In general, you won't have the reservation available if you're just running normally. So the reservation's only available for today when you're actually on the course. If you're using your accounts after the course is finished, miss out just drop the reservation. And that means it's reservation 196 because it's also generated by our systems team, and they keep a record of all the reservations that have ever been asked for. And so this one is for TA035 and _196. It's make sure that each reservation has a unique ID. There's no significance other than that. It's just something, a scheme we use to be able to set up reservations because we set up quite a lot of them. Hopefully you'll have a chance to have a go at that and come up with some answers. But I'll show you at least one way of going about it. So I'm going to remove this layer output for the moment. So let's edit our job script, and I'm going to comment out for the first one. I'm going to just comment out the account ID. So it won't have that. I'm going to comment out the number of tasks per node, so we can check that one. And I'm going to comment out the number of nodes, so we can check that one. And the final one was the SBatch. So we're going to comment out, the amount of time. There were the 4 things we wanted to check. So I'm going to take them out, and then I'm going to run the job and see what it tells me about what the different things look like. Sorry, what the defaults are if I don't specify them. So let me try submitting that again. Oop. I need the reservation, so I'm just going to get that out. There we go. Okay, so I get a warning, but the job's still submitted. It said the default time is short, but it doesn't actually tell you what the default time is. So you can cancel it and resubmit it if you wish. So let's see if it's finished. Should have finished pretty quickly. Yep. Okay. Excuse me. So okay, so it did work. Maybe something slightly funny going on with the placement now. So we can see the placement actually helps us understand what happens with the task per node and the number of nodes. Okay, so you can see at the top here where we got the summary. You remember in the last one, it showed us a summary of what our options were. This time it's saying we've only got 1 node. That tells me the default number of nodes in use was 1 node. And it tells me how many tasks per node by default as well, and it's 256. Oops. Sorry. Go back to the top there. It's 256. So if I don't specify 128, I get 256, which is including the hardware threads we talked about that we generally don't want to use. In terms of where the budget's been charged to, sorry, which budget the job's been charged to, I know that as well because this account only has access to 1 budget, which is the TA035 budget, so it must have been charged to that one. Okay, and the wall time one is much harder, so I'm actually going to show the solution for that one. So you could have put in to query the other things. You could have used these Slurm environment variables as well. Was another option to get it out, but I could just read it out of the XD high output. But getting the times more difficult. We need to look at the actual job record itself using the sact command, the set accounting command. So I could do that. Sorry. I know my my job was 470,307. Okay, and so the default wall time is actually 1 hour. You can see there because I didn't specify wall time, and that's the time. The time it was got. So you could use this for any of the ones actually as well to get them out. So you could ask for the account probably, I think. Yeah, and you can see it was charged to TA035, and you could do the same sort of thing with the other options if you looked at what the sort of options that sact can output. And so it's a little bit tricky, but what it means is by default, if you forget to specify things, you'll get 256 cores per node, you'll get 1 node, and it'll charge it to your whatever your default group is or your primary group is. In our case, we've only got 1 group, so you can charge it to 1 of them. We've already seen SQ. As I noted, to check status of jobs. As I noted before, if you just use SQ on its own, you get a huge listing because you see everybody's jobs, not just the running jobs, which will all have a NID associated with them, but also all the jobs that are queued. So you can get some sort of idea of how busy the machine is by looking at this, because the busyness machine is not just how many nodes are in use, but how much work's queued up as well. So you can see here, there's quite a lot of jobs queued up. Some of them are quite large. There's an ambitious 1,024 node job there. There aren't 1,024 nodes up at the moment, so that one's not going to be able to run. Most jobs are 1s to 10s sort of node size. There's some 94 node jobs which are quite large. Any bigger than that, no. So 94, the largest jobs in the queue at the moment are about 94 nodes, but there's a lot of work in the queue, so it is quite busy. Waiting for free space on the system. Okay, and like I say, you can use SQ-U and your username to show just your jobs. As you've seen in some of the warnings from the system, You can use the scancel command to kill jobs. If you've got a job that's running and you realize it's got something wrong with it, or there's an error with it, and then you can use scancel to kill it before it's finished. I wanted to say a little bit more about the srun command, which is the equivalent of MPI run, probably, which is more common across other systems. So you may have seen srun as well if it uses Slurm natively. Once you're past the header section, which we've discussed in some depth, there's the usual bits of the script which tend to load the required modules and set appropriate environment variables. One thing to note is you should also always set OMP num threads, even if you're not using OpenMP, you should set this to 1. The reason for this is that some of the underlying libraries on ARCHER2, the numerical libraries, particularly ones provided by HPE Cray, if OMP num threads is not set, they will look at the number of cores on a node and try and expand and fill them, if at all possible. To avoid potential performance issues with oversubscribing cores with work, set OMP num threads to 1 is always good practice on all of your job scripts. And then after you've done all those things, you'll usually launch your parallel program with the srun command, which says it's simple as srun really needs only 2 arguments. Specify the correct binding of processes to cores. It uses the values of sbatch to work out how many parallel processes to launch. So, in our example job script back up here, let me go all the way back up to where my example was there. It knows that you've asked for 2 nodes and 128 tasks per node. So it knows that in total, it should launch 256 MPI processes or MPI tasks. Okay, so depending on the values here in sbatch, srun knows how many parallel processes to launch. And the command looks like this. As I've said, hint no multi-thread says don't use the hardware threads, and distribution block means just place them sequentially within the node, sequentially to cores within the nodes. Now, sometimes on ARCHER2, it says often here, but maybe only sometimes, you might want to underpopulate nodes with processes. That is, not use all 128 cores on a node. Now, obviously, if you can make use of all 128 cores on the node, that's the most efficient use of the resource, right? Because that's all of the resource there. But they may not be possible for various reasons. For example, you might need more memory than that's possible. So if each process uses 4 gigabytes of memory, then you're not going to be able to run 128 times 4 gigabytes on a node because you'll just go beyond the memory available per node. Or you might want to access more memory bandwidth per task. So the more parallel processes you have, the more they're competing for memory access, and the less bandwidth each individual process has. And some applications are memory bandwidth bound. So actually, you want to maximize, it's the balance between the number of cores and the amount of memory bandwidth that gives you the best performance, rather than the number of cores just on its own. Now, using the sbatch commands, we can specify these sorts of underpopulations. So, for example, it says example 1, or the first one here is 4 nodes with 64 tasks per node. Right. So what I'm going to do is just edit my test job submission script. Oh, sorry. Called test job. I'm going to put these options back in. Okay, so we've got all the options there now. So this one says 4 nodes with 64 tasks per node. That's pretty straightforward, I think. So pretty straightforward to explain. You change that one to 4 for 4 nodes, and that one's 64, would give you 64 tasks per node, right? And that's only using half the cores on the node. So that was 4 times 64 is 256 tasks split across 4 nodes. So 64 tasks. 64 tasks per node. Okay. 8 nodes with 2 tasks per node and 1 task per socket. Well, that would be 8 nodes. It's pretty straightforward. 2 tasks per node. But this time we want 1 task per socket. And there's 2 different ways you could do this. Okay. I think the option it's going to show here in the solution will be using the n tasks per socket. There is an option to sbatch, which you can specify the number of tasks per socket 1, because Slurm knows about sockets. It knows how to do that. The other way to do it would be to change the CPUs per task to 64. And remember, I said that the CPUs per task is the stride between tasks. So when you've got 120 cores per node, you want the first one on the first core, and then you want to step across 64 cores and place the next one after that. Okay, so these two options achieve the same sort of thing, and it's just personal preference. Which one you want to use. Okay, and the final example here is okay. I'll answer that question in a minute. Let me just finish this final one here. So on 4 nodes, 32 tasks per node, ensuring an even distribution across the 8 NUMA regions on the node. Right. So the example solution here is 4 nodes, 32 tasks per node, and that would be 16 per socket with 4 CPUs per task. So that uses the stride and the end tasks per socket. Actually, you can achieve the same, exactly the same effect and leave out this option. Okay, because if you do 4 nodes and 32 tasks per node, and then say CPUs per task is 4, you go in steps of 4 across the cores on a node, and you end up with the same effect of distributing them easily. So the end task per socket is sort of redundant here. So the final one for that option would look like 4 nodes, 32 tasks per node, and then a stride of 4. Okay, so the first task would go on core 0, the next task would go on core 4, and so on and so forth. I think that's right, 0, 1, 2, 3. Yeah, so the next task is on 4, and then you just step in steps of 4 throughout the node until you place all 32 tasks. Okay, so actually, usually you can get almost any combination you want by specifying nodes, tasks per nodes, and CPU per task. Okay, unless you've got some very strange distribution. Those 3 options in combination should be able to give you the right sort of distribution. So let me before I just answer, I'll set this job running with this distribution. We'll look at the output to see what XT high says, and then I will answer Session's question. So let's do that, and I'm going to SBatch. Okay, so then SBatch, my authorized reservation is the same time again, it's submitted the job. So Session asks, if we underpopulate the nodes, and the remaining cores of the nodes could be used by other programs. So potentially, yes, you can launch, but not by other users, because the node is exclusive to you. So you could potentially submit another program to the same node to use up the remaining cores if you wanted to. In practice, the reason you're underpopulating is usually because you want exclusive access to more of the resources. So you want to access more memory per task, or you want more memory bandwidth per task. And if you then go and submit something else to the other cores on the node, then you end up just using up that memory bandwidth and that memory for that other program and defeat the object of actually underpopulating in the first case. Okay, so actually that's not often that's not very common, but it does depend on the reason you're underpopulating. If you've got a program that only scales to, or a case that only scales to 4 cores, for example, then you could submit 32 copies of it, but otherwise fit on the memory and all that sort of stuff. You could submit 32 copies of it to a node, no problem whatsoever. So you can subdivide the node and use little bits of it yourself. That's fine. There's documentation on how to do that in the ARCHER2 documentation. But other people can't use cores or nodes that you're using in your job, because the nodes are exclusively for you while your job's running. But within your job, you could split them up however you like. So if you had, you were doing, say, a parameter sweep, and you wanted to run 100 copies of 120 of a single node job, you could request 100 nodes and run 1 copy per node, for example, or even subdivide it on the nodes if you wanted to. So once you've got the resource, it's up to you how you use it. Right, so let's have a look at this job should have finished, hopefully. Oop, don't know why that's there. Let me remove that dodgy file. That must be that fully command I put it in. Get rid of that. So the job that I just submitted was 470348. So the output is here. So if you remember, this was 32 passes per node and four CPUs per task. So what you'll see is that we do 4 nodes. Each of them has 32 processes. We've still set OMP num threads to 1. You know, we haven't changed that yet. But you can see now that node 0, that rank 0, thread 0, the first process on the node can sit on any of core 0 to 3. Okay, the next process can sit on any core 4 to 7, and this is the stride that we put in to core that allows it to step in steps of 4. So you should see where we get to rank 31. Rank 32 is then on the next node, is on node 1. And once we get to rank, what is it here, 63, rank 64, the next one is on the next node. And then finally, once we get up to rank, sorry, I missed it, I went right past it, 95, which is the 96th one in reality, because we start counting at 0, and then rank 96 is on the next node. And so we used all 4 nodes evenly. So I hope that they can get a little confusing, the underpopulation, but it is useful, especially if you're running out of memory, and to be able to underpopulate nodes in that way is why we spent some time looking at it. Similarly, the similar underpopulation is also used for another use cases, which is where you're using both MPI processes and OpenMP threads, because then what you want to do is have your process and then use the stride to leave space for the threads in between each process. So this example we said here would be just as valid if you had 4 OpenMP threads per MPI process. So 32 tasks for OpenMPI tasks per node, and then 4 OpenMP threads per task. And the only slight difference is with a hybrid one, all the underpopulation stuff looks the same with the strides and things like that. But you also need to obviously set OMP num threads to the right number. And you also need to say that export this extra variable to tell it how to place the OMP place the threads. So in our example job submission script, I'm not going to run this one here. I'm just going to take this one. I'm going to remove all my old Slurm output files. I'm going to update my test job, and I'm now going to run 4 OpenMP processes because I've got enough space. OpenMP threads per MPI process, sorry. And I'm going to add the OMP places equals cores option there. I'm going to submit that job. Using the same sbatch command. Hopefully that's finished pretty quickly. And now we're going to look at it here. And so now you can see it's changed again slightly because we've got 4 OpenMP threads per MPI process. You can see rank 0, thread 0 gets bound to core 0, rank 0, thread 1 gets bound to core 1, and so forth, and so on sequentially until we're using all of the cores on all of the nodes. Okay. One of the challenges with ARCHER2 is because it has so many cores per node, there's lots of different ways of doing these things, and you have to be careful, or you can be quite complicated. In terms of OpenMP thread usage, though, if you're using full nodes, there's only 4 possible options really, because we talked earlier about these NUMA regions, and you never want threads from the same process to be on separate NUMA regions because it just kills the performance. So the only 4 options you really have are 8 MPI tasks per node with 16 OpenMP threads. So that's using the maximum number of OpenMP threads in NUMA region has, which is 16. 16 and 8, 32 and 4, and 64 and 2. They're the only real options for hybrid that work if you want to use all of the cores on a node. Any other options are likely to be inefficient. And hopefully you've also seen where the output from jobs goes. You've seen that by default Slurm places all the output, standard output and standard error into a file called slurm dash and then your job ID dot out. That's what we've been looking at. You can redirect both if you want to separate out the standard output and standard error by adding the SBAS options minus output file name and minus error file name. So if I, again, let's remove the slurm flag here, and I'm going to edit my job again. And this time I'm going to add, oops, sorry, sbatch minus minus output equals std out .txt, and the error I'm going to put instant. And I'm going to run sbatch again. So an exclamation mark in front of the command just reruns it with the same, exactly the same syntax you ran most recently in your history. And so I don't have this time any slurm dash job ID.out file. Instead, it's been redirected to these two files that I specified. So standardout.txt has all the stuff from XT high, and the standard error stuff should have all the stuff from modules, because modules always outputs its output to standard error. So I've split the two streams, and that can be useful sometimes when it's getting quite complicated to work out what's going on. No, so session asked about KMP Affinity. So KMP Affinity is an Intel thing. Okay, so the OMP places is the sort of generic. The OMP places, along with the SRun options of distribution block achieve the same effect as the KMP Affinity stuff from Intel. But KMP Affinity is an Intel thing, not a generic thing. There are some other things that can be useful. If you want to, you're still playing around, you're still debugging and trying to get things working, it sometimes be helpful to have access to be able to run things directly on compute nodes without a batch script, but actually just get access to the shell on a compute node. You can do exactly these sorts of things. You can either run things directly without having to write a script, though the command gets quite long. You could use srun directly like this, and has all the same sorts of options as sbatch as we've seen before, but runs the command directly, and you get the output straight back to your terminal. So I should just be able to copy and paste that. Oh, so I'll need to module load XT high this time. This is one case where you do have to load it in your interactive environment, because srun, if you use it directly, inherits from the shell you've already using, rather than starting from scratch like sbatch does. Nope, rest is invalid. It's invalid. Did I get the reservation name wrong? TA350196. Oh, I know why. I think. No, I don't know why. Oh, I see. It's got equals. There's an extra equals there. That's what the problem is. So if I get rid of this extra equals, there's a typo in the thing. Hopefully that should run pretty much straight away and give me the output from XT high that we expect. And if you look in the ARCHER2 documentation, you can see the syntax for getting a interactive shell on a compute node as well. You're using srun directly. So that was a quick tour through the scheduler on ARCHER2 and what's possible, the different options that are possible. Do people have questions before I move on to the final section? Or the final sections, sorry. Are there any edits to the graphical interface like gedit for people who are not either compiling the kind? So the code, so you can use Emacs with a graphical editor. You have to also be running an X server on your local system though, to be able to use graphical editors, obviously, because it has to be able to export the windows, and the performance is generally going to be lower like that, because X is really clunky and horrible in that sort of way. So I mean, one thing I say, yeah, people are familiar. I understand the point, but I think actually my point would be then, in general for using HPC facilities, it's worth taking the time to become familiar with a internal editor, be it VI, be it Emacs. VI and Emacs are the two classic ones. There's also Nano on here as well, which is another place, a good place to start. And a lot of systems have Nano there now, which is an internal editor, but it works like a graphical editor. If I press delete, it does actually delete things. It's not like VI, where you have to enter different modes, and it doesn't have the complex command gymnastics that Emacs has. And at the bottom, it just tells you, what the commands are to do things. So if I edit this and change it to 2 nodes instead, then I can output the file with Command O. It says with Control O. Sorry. So if I type Control O, it says file name to write, and I can just say I want to overwrite the file. So it's got the name in there already. So I just press return, and then exits Control X. And that's updated the file to go. So that's probably the closest thing you get to a graphical interface. But I think my advice would actually be to take the time to learn a internal editor like VI or Emacs. I'm not going to say which one, because different people have different preferences, and it stands you in good stead. If you're going to be using HPC, it's a useful skill to learn, and it's worth taking the time to do that. You don't have to become like super expert with it, but enough just to edit files and to manipulate files on the system. There are other options. One other option is to have an editor that can edit files remotely. So, for example, I use Microsoft Visual Studio Code a lot, which is a free editor you can download, and that has an option to add an add-in that can connect to files on a remote system. So I can edit files directly on ARCHER2 using Visual Studio Code once I've SSH'd into the system. So that sort of option could work well. It generally works better than trying to export things over X. Both Emacs and VI have modes where they can edit files remotely rather than trying to export the display back from the HPC system, and they tend to work better. But honestly, really, there's always a chance you're going to be stuck with graphical export not working for some reason. You're working on a system that's too far away. Like I work on systems in Japan. What's the name of the add-in on Visual Studio Code? I'll look it up and put the link in the chat over the break for you. Okay, so that's the schedule. The next section is how to be a good ARCHER2 citizen. So I'm just going to go through this section quickly, and then we'll have a short break, and then we'll finish up because I did promise we'd be finished at 4 o'clock. Okay, so one of the things compared to using your laptop and all that sort of stuff for HPC systems, of course, is the shared systems. Now, of course, it's our responsibility as the people who run the system to make sure that as much as possible, that people can't break the system or abuse it or affect what other people are doing on the system. Okay, but there are still ways that you can make the system less usable for other people, and it's useful to be aware on a shared system of what those things are and how you can act to make the system as usable as possible. Because if everybody acts that way, it's as usable as possible for everybody. So if we're all good citizens, it helps all of us together. So one of the main things actually is, as a responsible user, there are certain places where we share the space more closely with other users. The two classic examples really on HPC systems now, especially ones like ARCHER2, where the nodes are not shared. So you have exclusive access to a node for your own use, is when you're on the login node, which you share with lots of other people. I can show you that because I can check who's logged in at the moment. So I just type who. It'll show me all the different people logged into this login node. There's quite a lot. In fact, let's find out how many. So there's around 200 people logged in at the moment using this one login node. Okay, some people obviously seem to be logged in twice. So there's somebody who's logged in twice to the same node. But that's a shared space, and the other one's the file system. And we all share access to the file system. So things that one person does on the file system could affect the performance that other people see. But the login node is usually very busy. It's designed to be able to deal with that load, and generally you don't see any lag. We set up the login nodes as the service to try and minimize the effect of the users can have on other users. So we try to set some sort of flexible limit so you can't break out and just stop the login node running for other people and slow it down, which is the classic one. But it's not perfect, and we can't make it perfect. So being careful about what you run on the login node is generally the responsibility of users. You can run things, so you don't run jobs on login node. Okay, so now I'm asking, when you use srun directly with the client, does that batch it on the compute nodes, or does it simply roll them? It goes onto the compute nodes because it goes into the queue and is launched on the compute node. So anything with srun in front of it always runs on a compute node. Okay, at the moment anyway. So you can run some quick tests on login node and some analysis and things like that. You can't run parallel parallel MPI jobs anyway, because MPI is not supported on login node generally. There are ways around that, so you can make that work. But it's generally a bad idea, because taking up lots of resources is both not good for other people. It's not good for you as well, because all will happen is things will run very, very slowly because the login node's sharing access to lots of people. So sometimes, everybody makes mistakes, and will run a command at some point that uses lots of resources and then realizes their mistake and kills it, or doesn't realize a mistake and gets a message from the systems team saying, we noticed you did this thing, please don't do that again. That's okay, everybody makes mistakes, but sometimes we just need to think in advance of what we're doing. So, that's actually broken there. So for some reason, so it's had these examples here of which of these commands will be okay to run a login node. Python physics sim.py doesn't sound great. It sounds like simulation code. I don't think I'd be doing that. Make, it's a classic command for building executables and building software. That sounds fine. That's exactly what login nodes is designed for. Create directories.sh, probably okay. Depends how many. If it's creating a million directories, then no. But, as long as it's okay, as long as it's set up properly, that sounds fine. Molecular dynamics doesn't sound too good, but uncompressing a tar and expanding a tar archive, and this one containing the R software, is fine. That's exactly what a login node is designed for as well. Okay. If you see any problems with the login node, like performance or slowdown or anything like that, please report it to the service desk, because it's useful for us to know. We do monitor things, but, we are monitoring, again, as in our controls on login node are not absolutely perfect. So sometimes it's useful to have report, it's often useful if users are seeing specific things for them to report them to us. The other key thing for the login nodes is don't use ARCHER2 logins nodes to log into other external services. So outgoing SSH connections will be killed. Camilla asks about how to access a data analysis node. So they're not actually available on the system yet. They're not around until the full systems is available later in the year. And then the data analysis nodes will be available, and the documentation on how to access them will be in the user guide. The plan is that they're going to be available via, in the same way as compute nodes, via SBatch and srun. So you can either srun things directly, or you can SBatch a job submission script, or you can srun to get an interactive shell on the data analysis node if you want. Those ones will be slightly different from the compute nodes in that they'll be shared across users. They will be exclusive. So you could ask for a single core, for example, on the data analysis node, and the other cores could be used by other users. So they will be slightly different from the compute nodes in that sense, but the mode of access them will be the same as the compute nodes. Another tip is, or other things are, never share your login credentials. Okay, it sounds maybe, I feel sometimes when you were saying these things that, actually, we're being a bit basic for people, but the number of times we have, evidence of the system logs show evidence of people using other people's accounts or logging into other people's accounts, you'd be surprised at how often that happens. Okay, if we detect this, we'll ask you to reset your access credentials. That means you'll have to generate a new SSH key, and we'll reset your password, and you'll have to generate a new one. Similarly, accessing another Archer2 user account from your accounts, even if the two of you are sat at the same desk, say you're co-working with a worker. Sorry, this is obviously, I'm still in pre-COVID phase. Hopefully we'll be back there at some point in terms of working close to each other. But we often have people sitting at a desk and they say, oh, I just want to show you this file. I'll just SSH to my account from your account on ARCHER2, or I'll SU to my account from your account on ARCHER2. That also is not allowed, because it allows the person whose account you're starting from to potentially capture the credentials for the other accounts if they have some sort of keylogger or something like that on the system. So if we detect that sort of behavior as well, we'll ask both people involved to reset their access credentials. Okay, because these are all forms of account sharing, and one of the terms and conditions of access to ARCHER2 is that you do not share your credentials with anybody else. Okay. On a more practical sense, test before scaling, right? ARCHER2 is quite a big resource. Even the little ARCHER2 we have at the moment, which is only 4 cabinets, is still very big. It's 120,000 odd cores, more than 120,000 cores. Okay, so there's the potential to use a lot of resource very quickly by mistake. So, for example, imagine a job script for mistake that makes it sit doing nothing for 24 hours on even 1,000 cores, which is not very much of ARCHER2. Or one where you've requested 2,000 cores by mistake and only use 100 of them. You'll still be charged for all the resource you're not using because it's not available to other users. So you can burn through your budget very, very quickly. And the classic example we see is this, where somebody's written a job script that automates submission of multiple jobs or something like that, or run the same calculation analysis of lots of different input. And you can end up using up all your budget and also blocking other users from using resources that actually aren't being used properly. And similarly, in a similar vein, you might have a small typo in your job script that causes it to fail. You might end up in a busy period waiting, say, 24 hours for your job to run, and it fails within 10 seconds because of just a typo in your job script. And this is extremely frustrating. I speak from experience. I made this mistake. I still make this mistake often. So I'm not even following my own advice here very much. But using test job submission scripts is a really good way around this. There's the short QoS, which allows jobs to run very quickly or small, so scale back the resources, and instead of actually running the job, just get the script to print out what it would have done at that point before you go and submit big, large runs, particularly when you're running very large automatic runs. Submit the job to truncated test to ensure it starts as expected and that it works as expected. And you add these options either to your job submission script or on the command line, as I said earlier, which overwrite them to use the short QoS, so you can try things out. Having a backup plan is very useful. We talked about data back at the start. So disks do fail, right? The home file system's backed up. That's fine. So if the disks fail on the home file system, you should be pretty much protected. But the work file system is not, and that is often the file system you're using day to day on ARCHER2. And disks do fail on work file systems. People have lost data on HPC systems because of hardware failures. If your data is critical, don't leave it lying around on work for long periods of time without some sort of backup or compression or copy of it elsewhere. We do occasionally get emails from people where data's been lost, and they're like in the 3rd year of their PhD, and they don't have a copy of it elsewhere. I mean, I'm sure all of you have heard stories of the PhD students sometimes whose laptops have broken, they've lost their thesis, and all these sort of things. The same applies for HPC systems. The data there is, what you're working on. It is your work, so you should be protecting it and looking after it. So make sure that you've got anything critical that is going to be really difficult to regenerate is backed up somewhere else other than on ARCHER2 itself. And we talked earlier about strategies for transferring data to try and optimize that. Use those strategies and think about having some sort of data management plan so you know which data is critical and which data you have to have a copy of elsewhere. As it says here, the time required to transfer large amounts of data shouldn't be underestimated, because as well as the actual physical time it takes over the bandwidth of the connection, the fiddling about getting it set up and getting it working, getting the connection stable is actually always more than you think, and is more painful than you think it should be. So do have a plan for that. And unfortunately, your data is your responsibility, really, right? The service doesn't have responsibility for users' data on the system. In fact, we have no visibility of it in general. The only people who have visibility of all the data on the system are system administrators who have access to the password, and they are very careful in terms of what they look at and their discipline and how they use that access. So, we do not have responsibility for your data. We do not claim any responsibility for your data. We will do our best efforts to keep the system running and stable. We'll do our best efforts to make sure that the backups of home are accurate and proceed as they should, but there is no guarantee. Your data is your responsibility, and it's up to you, if the data is critical, to make sure you have copies of it that you are confident about. We talked about data transfer. What we didn't mention a bit, I think, was the sort of technical bottlenecks in terms of what might be transferring data. One of the things is disk speed might bottleneck it. So the ARCHER2 disks are very high performance, server class, and some of them are parallel file systems with very high parallel write and speed. The place you're transferring it to might not be the same. So you may end up limited by the disk speed of where you're transporting it to. Okay, so you could get very high read rates from ARCHER2, but you get very slow write rates at the other end, for example. Metadata operations we mentioned, that's the sort of having lots of files. So if you have lots and lots and lots and lots of small files, you tend to find the performance is bottlenecked on the number of files rather than actually on the amount of data you can really transfer over the internet or over the network. Try and combine your files and archive them together. Sometimes it can be network speed, and one of the classic ones here is, ARCHER2 is in a data center with high quality connections out to the UK academic network called Janet, and that in turn has high quality network connections out to the rest of research networks across the world, and also out to places like AWS and Azure and these sorts of things. But if you're transferring, say I've got my laptop here in my house and it's on a Wi-Fi connection, I can get as fast network data connection off ARCHER2 as possible. But that last bit of going from my network router to my laptop is probably going to limit the amount of the data transfer speed I can do, especially upload, because often people's, especially when they're on an ISP working at home, which is much more common now, the upload tends to be much more throttled than the download speed. And firewalls can cause a problem too. So, we have a special setup on ARCHER2 that means we exist with minimal firewalling or outside the main university firewalls to be able to have the maximum data transfer forwards. But general firewalls are usually optimized for things like email and web browser traffic, not for large volume data transfers, and they can throttle data transfers as well. Most institutions have a place where you can transfer data to outside of the general university firewall that is subject to specific limits set up for large data transfer. They're often referred to as DMZs or demilitarized zones, or data management zones sometimes as well, where you can transfer your data without being exposed to firewall throttling issues. But you need to speak to your local institution about that. So there's lots of things to think about there, and I feel like I'm overwhelming you with information about data transfer. But we see it so often that people get to the end of projects and run into problems getting their data off, and it's just stress and it's just panic that can be avoided with a bit of planning ahead, which is why I'm trying to push it on to people so much here, because nobody likes being stressed and worried about their data and where it's gone to. So it is worth taking the time to have a think about it. So that's it in terms of the being a good citizen. So in summary, there was the be careful how you use the login node. We also talked about testing before you actually run big things, so you don't waste a lot of resource. Data on the system is your responsibility, and have a plan for transferring it. As it says here, don't run stuff on the login node, and please don't be a bad person and run stuff on the login node. So but I think the login node controls should help that with they're much more sophisticated than they used to be. So that isn't as much of a problem. But thinking about data is much more of a problem than it used to be, because everybody's data requirements are bigger generally now, and it takes a lot more thought to manipulate larger amounts of data. So, so that's another break. I'll answer Session's question. My plan is for us to come back probably in about 20 minutes, which would be about 25 to 4, and just do the last little section then, and then have some more time for questions if people want them before we finish up. So anybody who wants to go and grab a drink, we'll start again at 15:35, but I'll answer questions here now as well, because there was a couple of them. So Session asks, I want to ask SS ARCHER2 from my home machine, and also in the future, assuming everything goes well, my office machine. So can I copy the ID RSA onto both the machines? Is this strategy safe? So there's a trade-off here. So yeah, the technically right security answer is no. That's not particularly safe. Okay, but there is a trade-off. There's different ways of doing things. One of the ways I've managed this before, speaking from personal experience, is to have an encrypted USB key, which has my credentials on, my keys on, and then I can just plug it into whichever machine I'm at the moment. I can carry it around with me. I can plug it into whichever machine I want. I can have a backup key, which I keep at home. So if I lose that key while I'm out and about, it's not a big thing. It's encrypted anyway, so the risk is low if somebody steals that USB key. Okay, and that means I could just have those credentials, and reuse them on different systems. Okay, that used to work very well. Now, when you go to libraries and places like that, often the terminals you get access to don't have a USB port exposed, which means it's less powerful than it used to be. Having multiple SSH keys is the other way to go, and having one on your home system and one on your work system, for example. And Safe and your account on ARCHER2 supports that. You can upload as many SSH keys as you want to Safe, and then have them use them from different locations. And I guess that's the sort of canonical right security solution, because then the key's not shared. You're not copying your key around to different systems, which sort of defeats the purpose of the key. But obviously the risk's larger there because you have multiple keys now available to access the system. It's not as big a problem on ARCHER2 because you need your password as well. You need both factors. So I'd say, so this is a long and roundabout way of getting to the answer of say, it's a balance between security and convenience. What suits you, what suits your method of working? Is it better to have, does it suit you more to just have two separate keys and just not have to worry about carrying things about? Or your other option, like you say, is to actually just copy them to different systems, or like say my old solution, which was to carry around my keys on an encrypted USB drive, just wherever I went, and just have it like attached to my keys or something like that as part of a key fob. I don't think there's any really strong arguments either way, I have to say, in terms of what you're saying. So it's up to you, I would say here. As long as you take care of your keys and are careful with them, then I don't think there's any huge problem with having the same key on two different systems. But equally, if you prefer to keep them separate, then you can. It's quite easy to have multiple keys because you could add the multiple keys to your account via Safe and ARCHER2. That's quite a nice solution. I don't use it at the moment actually because my USB encrypted key is turned into my laptop, which I just carry everywhere with me. So there's no point carrying the key as well because I actually just carry the laptop everywhere. And have my keys on the laptop, which is an encrypted drive. So it's just I have a really big USB key now. But then I don't have a desktop system at work. Yes, now ask, can we use Git, download, update repos? Yes, you can. and Git's a really good use. So the login nodes can see the internet to push and pull over HTTPS or whatever you want to do like that. The only thing we don't want people doing is SSHing out onto other systems. You can use the login nodes to SCP out to other systems as well, but it's the interactive SSH that's really frowned upon. So Naman asked about the Visual Studio Code extension for editing over SSH connections. So I'll put the URL for the Visual Studio Code tutorial in that supports that. That link should take you to step-by-step instructions how you can set up VS Code to edit files, for example, on ARCHER2. And one thing I would say is that if you're going to do that, you may need to be a bit clever about your keys. So one thing you may have noticed when I log into ARCHER2 is I never specify I haven't been specifying my passphrase for my SSH key. Okay, which usually you'd expect to have to enter both your password and your passphrase. The reason I'm not having to do that is because my SSH key is stored in an SSH agent on my system. So that means it's, when I first start up my system, I add the SSH key and I type the passphrase once and that adds it into the agent, and then the agent offers that SSH key when I log into ARCHER2. And knows the passphrase. When I switch off my machine, I then have to re-add it again. But when you're using some of the Visual Studio Code extension, having the SSH key in an agent really helps, because it means you just need to enter your password once to set up the connection for a Visual Studio Code. Once the agent's running, you don't have to worry about entering the SSH key passphrase as well. So if you're going to do things like remote editing of files, I'd highly recommend getting SSH agents up and running, because it'll make it much easier for you. Hi everybody, welcome back. We've got most people, so given we've got less than half an hour left, what I'll do is I will get going and go through the final 2 sections of the course today, and hopefully then we'll have a bit of time left at the end for people to ask questions if they want to ask questions. Let me stop this poll and look at the next 2 sections. So the next 2 sections really aren't about running on ARCHER2 per se. They're around some of the things you can do to get support and using SAFE, which is our web-based interface for service management and user and account management and those sort of things. And then after that, I'll talk about what comes next after this course, and potentially where you can go next in terms of accessing ARCHER2 and getting further help training if you want, and various bits and pieces like that. So let's have a quick look at SAFE first. So SAFE, you'll have already seen because you have to use it to get an account on ARCHER2 for this course. It's a web-based tool. We develop it. And it allows you to manage your ARCHER2 account. It allows you to, for example, record research outputs linked against your use of ARCHER2. They're used in a couple of different ways. I'll mention a bit further down. It allows you to look at your historical use of the ARCHER2 service, what jobs you've been running, get reports on how long they took and how much resource you've used, but also things like we use it to report on what applications people are using on the system, and have a look at the statistics in terms of job wait times and any work we need to do there. So we use it in those ways. And if you're a project leader or manager, it allows you also to manage your project's resources on ARCHER2. That's it. Divide it up between your users in your project, divide up quota, get reports on who's using what, and things like that. There is a separate SAFE user guide which has documentation on it, and that is work in progress. It's got most of the stuff there, but it's not completely complete yet. But we are working on that as we speak. So in terms of accounts, hopefully, I guess you should already realize you have 2 accounts associated, at least 2 accounts, sorry, I should say, associated with the use of ARCHER2. Accounts on the SAFE web tool, and the ARCHER2 login account, which is sometimes also referred to, or a machine account. Now, you can have multiple login accounts associated with a single SAFE account. So I could show you this on my one, let me get our web browser up with Safe. Okay, let's not go to the help desk. Let's just go, in fact, let's just go to ARCHER2, and then there should be a login to EPCC Safe button there. There you go, and that's the front page of the Safe. Make it a bit bigger. So, you can have login accounts. I've got lots of login accounts for various reasons. One, because, I get a different login account for each course. I also have login accounts that are on different systems that are managed by Safe. And I have login accounts on Archer for various software packages that I help manage. So I have one Safe account and lots of different login accounts. And some of those will be on ARCHER2, and potentially some of them are on other national HPC resources that are managed from Safe as well. And so you can actually have multiple login accounts on multiple services associated with a single Safe account. But we're not going to go through everything that Safe does here because it does a massive amount of stuff, but we'll mention a few of the most useful things. So the Safe account allows you to manage your login counts, look at your resources, set contact details, preferences, code research outputs, and things like that. But one of the most useful things you can do here is you can link your institutional single sign-on. This works very well, particularly if you're a UK institution, because, sorry, I got a bit of an echo there. This works very well if you're a UK institution, because all of them support the right sort of properties we need to do this on Safe. But for some of them international institutions, it can work, and for some of them, it doesn't work so well. So it depends a bit what your institute, how well your institution supports this sort of federated access. But if you look on Safe, there'll be a way here to register. Sorry, in your details, there's a register identities section, and you can register an institutional ID. That'll take you to a page where you'll be able to select your institution, and then that will redirect you to your institution's login. And once you've logged in there, it'll be linked to your Safe account. And then when you, if I log out here, when you come to log in Safe, instead of using the email password login, you can use the login with institutional credentials there. So my one's University of Edinburgh. If I click on that, I'm already logged into my single sign-on. So it lets me log into Safe using my University of Edinburgh credentials. Okay, and that should work for most UK institutions and definitely some international ones too. That's quite a useful function, saves you having to remember more and more passwords. You can change your email notification preferences. There's various different mailing lists you can subscribe or unsubscribe to. There's a major announcements one, which is low volume and used for high quality important announcements on major system upgrades and major issues on the surface and things like that. I recommend you keep yourself subscribed to that one. Definitely. We do have a sort of super important nuclear button that we can use to email everybody no matter what their email preferences are, but we hardly ever use that. It's only in for something very, very extreme like this service is the end of service, it's the end, service is shutting down for good, please get all your data off the system sort of emails. And so that is hardly ever used. There's a service news emailing address, which you get a weekly email with information on changes to the service, upcoming events, training courses, and all the useful information. People, and finally there's the system status notifications, which gives a bit more information on when the system's going up and down. For a lot of people that doesn't matter, so or they don't like that information, but for some people it's really useful for them to know more about when the system's going up and down so they can plan their work more effectively. But for a lot of people that doesn't matter. Okay. So you can change those sorts of things in Safe. So here in my details I can update my email settings, and you'll see here that I'm ticked up to everything. There's the old user mailing that's hardly ever used, that's mandatory tick, but I've checked the other ones because I want to know what's going on, and also it's useful for me to see when I send an email that it's actually gone to the right people. So your Archer login accounts, ARCHER2 login accounts rather than your Safe account, you can have multiple ones. I've already shown you the login accounts menu where you can see the different account. If you go and select a particular account in there, so I could go and select the one for this course, for example, which is this account here. It gives me some details about what the machine is and whether it's active, when I last ran a job, which is only updated once a day, so it's out of date for today because I ran a job. You've obviously seen me running jobs today. It shows me which projects I'm linked to, and it also shows me my disk info. So my user disk info is my usage and files. If there was a user quote, it would show it here as well, but there isn't one on this project. For the whole project, it shows me how much budget's remaining for the project, and what the quota is on the work file system and the home file system. Okay, and they're group quotas, which are enabled for this system, for this project, sorry, and how many files and usage across the whole group. And then it shows me my credentials. So here's this is my public SSH key hash for connecting to the system. So your one should have like those as well. And we already saw the request access to package. If you wanted, we spoke a moment ago about adding multiple SSH keys. You could do that here through the add credential, and you can select an SSH public key and then upload it in exactly the same way as you did when you first set up your account. And you can also delete credentials. Say you've lost a key and you don't want it to be able to access ARCHER2 anymore, you can remove that credential. And those sort of things. If you forget your password, you can request a password reset here and pick up your initial password again once it's been reset. One thing to note about the passwords, I can view my login account password here, but it'll still show me the initial one-shot password. It isn't kept up to date with the changes on the system. So when I first logged in, it prompted me to choose a new password. That new password does not propagate back to safe for obvious security reasons. So if you forget the password that you set, you do just have to request a new password, get another one-shot password you can use to log in, and then change it again to a new password. Okay, so safe is not kept sync with your password on the system, because that means that if somebody broke into safe, they'd be able to get passwords for the system, and we don't want that. We only want, potentially, the single-use passwords tend to not last very long, so they're not as much of a security risk to have in safe. So I've talked about that and talked about adding SSH keys, and we talked about requesting access to licensed software before. You go to the account, you press the button, you choose the software package, you provide the required details, we check it, and if you're authorized, we grant you access to the software. You can also record research outputs. So the safe will let you put in a DOI into your account and associate it with a particular project. So if I go to the safe here, again, on your details, there's publications. So I could choose whichever project I want. There's lots of projects here I'm a member of. So here's the project for this course. And then I can go view and I can add a thing there. So I just type in the DOI, safe automatically goes away and gets all the metadata associated with that publication and associates it with the account. This is really important for a couple of reasons. One is that we use this data to justify to the UK government why HPC and computational science is really important, and get funding for future services, and funding for expansion of services to make more resource available to people. But also it provides a convenient way for people in the UK. Every time you have a grant, you have to submit once a year all your publications and things like that to ResearchFish for the Research Council. Safe will output the data in a format that can just be dropped into ResearchFish. Now, this isn't so much of a problem if it's just you and your project submitted to ResearchFish, but some of the projects have hundreds of users associated with them, and Safe goes away to collate publications from everybody in the project, which then produces one big long report that can be pushed into ResearchFish. So you can use the DOIs in that way. They also go up onto the ARCHER website. So if we look at the ARCHER2 website, under the research section, there's actually a publication section, and this list is automatically pulled from the DOIs that people have put into Safe, and gives a public record that we can show again to funders and to the government and say, look how important computational research is, and please continue to fund it. And finally, Safe allows you to report on your use of the service. So it provides reports on what jobs you've run, how much resource you've used. This is often used by project managers and PIs to assess how much, how they're proceeding against using the resources of the project, and if different, if there's people they need to speak to about overspending or underspending and things like that. But also for you, you can go and see, which jobs ran, how much they were charged, and those sort of things. So if I go back here on the service information tab, there's a report. If I switch off, just a minute, I've got special, oh, no, I don't have my special privileges on, I don't think. So I can look at a user job report for I wonder if there's anything from this account in for this project in yet. So that's my account on Archer for the last month or so, for the 1st of the 7th. Actually, I want it for the 1st of, not the 1st of July, from the 1st of August would be better. And maximum jobs 25. Let's see if I've run any jobs. Okay, so it has records of some jobs I ran, probably test jobs I ran yesterday in preparation for the course. Yes, you can see the 2 jobs there. Job IDs, when they were submitted, start, end, runtime. A scheduling coefficient tells you how long it queued for, in some sense, what the size of the job and how much it was charged as well. So you can always get a record out the safe of what your jobs were and what the charges were for them. And that's safe. So it provides a way of managing your accounts, looking at your usage and some other convenient features for getting information from the service and providing, for example, research outputs back to the service to help us justify usage and to help PIs collate information for input into other tools such as ResearchFish. And we also use it to manage our service desk and various other bits and pieces to help settle projects and report back to the research councils on, overall usage of the system, overall queue state. Are people waiting too long for jobs to run? Do we need to make more resource available? How much resource do they have to give out in the future? Those sort of things. That Safe provides all that functionality. So we've got just over 10 minutes left until the scheduled finish time. Like I say, I'm going to stick around a bit so people can ask questions if they want, and talk a bit more about their usage. So Naman actually asks, does ARCHER2 also have a driving test? So I guess this is motivated from ARCHER1, where there was the ARCHER driving test where you could complete a small online questionnaire to show that you knew enough about ARCHER to be able to use it effectively. And then you got a small amount of time for personal use to either explore the use of the service or to do something that you wouldn't be able to otherwise do via your budget, via another budget on the system. So there is not currently an ARCHER2 driving test, but there is one planned, and it's for when the full system's available. Because we're on a smaller system at the moment, the research councils felt the reduced capacity meant that they couldn't really justify the driving test access route right at this minute. But once the full system's available later this year, then the driving test will open up, and that'll be available for anyone who's based at a UK academic institution to be able to complete a simple online quiz and then get access to ARCHER2 to try it out for their research, get a small amount of resource from them to try out for their research. So it's coming, but it's not there at the moment. Is the answer. In terms of next steps, so the 3 things I'm going to look at briefly here are where you can go for further help, because we've had some questions about, how do I install software, how do I get access to this package, things like that, where you can get that sort of help. What other training you can get access to beyond this course, because this is quite a basic practical introduction. Like I say, it doesn't include any conceptual information and information about HPC that you might want if you're newer to HPC, and how you can get access to ARCHER2 for your work, for your research. So in terms of getting help, the 2 key things are the documentation and the service desk. So the service desk is probably the easiest way to get in touch with us. There's the support at ARCHER2 AC UK email address. Whatever your question is, we'll do our best to answer it. And if we don't know the answer, for example, if it's about another service or ARCHER2 is not appropriate for some reason, then we'll try and point you in the right direction as far as we know. We have a pretty good overview of what else is available across the UK in terms of high performance computing and advanced computing stuff. So we can usually point you in a useful direction if you ask questions about that sort of stuff. If you're asking something specific about ARCHER2, either something's not working properly, or you have a request for some help with installing a piece of software, or you're running into problems, or you want a bit more information about the service that you couldn't seem to find in the documentation, then we can help you with all that. If you think you know, if sometimes if it's easier, you can request it, or we might suggest it to have a call back from an expert in the computational science and engineering team, who contact you either over Zoom or Teams or whatever your preferred method of communication is, and could sit down with you and screen share and chat through your issue with you, or you know, say you're, you know, and that's for the technical topics in terms of using ARCHER2, but also things like, you know, what's the best way of doing this type of calculation. We're always open to try and help people with that and have a chat with them about it. So please don't be shy about getting in touch with us. We try, we're quite proud of our documentation and the amount of effort we've put into it and the amount of information that's there. And we think it's pretty extensive and pretty comprehensive, but there will also be gaps and things missing. And the problem with it being extensive and comprehensive is there's a lot of information there, so sometimes it can be a bit harder to find what you need, especially if you don't quite know what you're searching for. The documentation has in it a quick start guide. There's one for people who just want to get on and use software that's already on the system. There's also one for people who want to get on and build their own software. There's the user and best practice guide, which covers all aspects of using the service. It's sort of the traditional user guide, more traditional user guide. And then there's information on all the separate different bits of research software, tools, and utilities, and we're adding to that all the time. If you find a mistake or you think there's something missing with the documentation, please let us know. If you're happy with GitHub and using GitHub and things like that, then you can even contribute to the documentation yourself. It's a public repository on GitHub, which anybody is allowed to issue PRs against, and they're just moderated by the ARCHER2 service. You know, so if you prefer, rather than emailing the service desk, to raise things as an issue via GitHub, or you see something you want to add and you think it'd be useful for the users, then you can just issue a PR against the documentation and contribute to it directly in that way. So that's there as well as a resource. One of the actual useful things it has as well is a known issues section. Let's see if I can find it here. So in the documentation, as well as the research software and all the usual sorts of bits and pieces, this is the link to the repo. There is a known issues section, which goes through some things that were known to fail on the system, and that's always worth looking at. You know, if you see some weird error message that you don't quite understand, or there's a piece of research software missing that you think should be there, just check the known issues before you email in. That doesn't mean you can't ask us questions about it, but we may just point you at that if you haven't looked at that already. In terms of next steps, in terms of training, there is hopefully from registering for this, you'll see there's potentially lots of training available on the ARCHER2 website. In terms of where you go after this particular course, there's a few potential routes to go. The next course the next two courses in the flow down from this course, or duplicates this course, are probably the Understanding Package Performance course, which is a course designed to improve the efficiency of your use of HPC systems. It's more generic than just looking at ARCHER2. It's useful no matter what HPC system you're using. What it does, it introduces basic benchmarking techniques that you can use, and concepts that you can use to try and optimize your use of HPC systems without being a software developer. So it's not designed for software developers. It's designed for people who use research software on HPC systems. Similarly, the using package whatever efficiently on ARCHER2. There's a few of these. Sometimes we've definitely run LAMPS and CP2K and GROMACS in the past, and we have ideas about running other ones of those. Go on in a bit more depth about those particular software packages, and they are quite often focused on ARCHER2 in terms of getting the best out of ARCHER2, but are more generally useful for people even if they're using other HPC systems. Generic courses on improving your software and data analysis skills, so the software data carpentry. I mentioned them right back at the start from the carpentry people. We run those courses as part of the ARCHER2 offering, and you can sign up for them there. And there's also, if you're interested in finding out more about Docker and Singularity containers, which are more general use, you know, they're not just for developers, they're general use for anybody using HPC systems. And there's a course we run as well, which is reproducible computational environments using containers. So all of these courses are free to everybody. There's anybody from an academic background, not just in the UK, but around the world. And if you look at the ARCHER2 website, what you'll find also on the in the training section, there's the upcoming training, which is the current courses you can register for. Okay, and there's not so many, but more are about to come online. One thing I would point out is that the Understanding Package Performance course is running at the end of October, which is one of the courses I highlighted in terms of follow-on from this course. So if you're interested, you can go and register for that course there. If you click on there, it will give you a bit of an overview of what that course is about, and see whether you think it fits with what you want to be able to do. But also here, we have a description of all the courses we offer and workflows through them in terms of how what is maybe a useful way through courses, and some descriptions of the different types of courses available. Not all of them are available at the moment in terms of running them, but you can keep an eye open for the courses opening, because we tend to run them all at some point. But if you want to get a better idea of what those courses look like, or even follow through them on your own, the training materials repository here has all the material from all the previous courses, and usually recordings of the sessions, the lectures and things like that. So for example, say if you're interested in the containers course, there isn't one to register at the moment because we've just run one quite recently. If you go and look at the reproduction of computational environments using containers, using Docker and Singularity, there's links to the course materials here, and then there's also videos of all the sessions that were throughout that course, so you can always follow through yourself if you want, rather than waiting for the course to open up. So feel free, that's just openly available to everybody to use if they want, as a resource for them. So there's lots of training available, and it's available for free if you want it. Especially at the moment where everything's online, and it's very easy for people from all over the place to access the training. In terms of getting access to ARCHER2 for your research, I said, somebody asked earlier, and we said that that these course accounts will remain open to you for the next 3 or 4 weeks, for you to play around with and try out the service and see and explore. There are a few different routes. Looking at the website is probably the best place has the most complete information. So in the support and access section, there's a get access page, and there's various different things. There's calls for ARCHER2 time only, so they're peer-reviewed access, but only for CPU time. So you've already got an ongoing program of research. You just need the computer time as part of it. So there's a few of those. There's a pump priming, which is a sort of try it out for 6 months, small amount of resource for 6 months to try it out. These access to HPC and Pioneer project calls, which open occasionally. The access to HPC call is going to open soon for software for research in EPSRC remit, and that is just quite a lightweight peer review process where you apply for access just for the computer time. And you can apply for access for ARCHER2, but also to all the other tier 2 HPC resources around the UK via that route. And sometimes there's a top-up call as well. Somebody asked about the driving test. That'll open when the full service opens. You could also add ARCHER2 to grant access. So when you're applying for research funding, you can add ARCHER2 in that way via UKRI calls in particular, fellowships and responsive mode and various other things like that. You can also add it to non-UKRI calls, but then there's a longer lead time because the Research Council's UKRI have to discuss with the External Research Council about, how the access is made available. So, if you're not using UKRI, then talk to us as soon as possible. One of the simplest routes actually might be via the high-end computing consortia. So EPSRC supports a number of high-end computing scientific consortia that bring together people from a common area together. Then they have access to a large amount of resource that they can dole out themselves. On the website, there's a link here to the ARCHER2 Scientific Consortium, and that lists the high-end computing consortium and gives you access to the website, so you can find out how to join them and how to get access to the resources. And you can see they cover a wide range of different use cases, from turbulence, CFD sorts of stuff, materials chemistry, and this is materials as well, car Parallel, biomolecular simulation, plasma science, mesoscale engineering, combustion, which is turbulent reacting flows, and optical physics. So you can go and look at those consortia as well, and potentially get access if your researchers in that area via that route. So there's quite a few different routes. It's quite complicated sometimes, the access, to just try and decide which route to go for. If you're in doubt or you have any queries, or you want to speak to somebody, please contact the service desk. We're happy to chat to people about the best access route. Finally, that's my final thing. ARCHER2 also includes some funding for doing software development. So if you have a piece of software you'd like to see improved by adding some functionality, or improving the scaling, or improving the performance, then you can get money to do that via ARCHER2, via these ECSE calls, where you can either get somebody at your local institution or somebody in your group to get some funding to work on software, or you can pay for somebody from the ARCHER2 team at EPCC to work on your software as well, or an RSE of your choice, so a research software engineer to work on your software. So there's that option as well, to get funding that way to do software improvements. So that is just at 4 o'clock, or just after 4 o'clock, and I've finished. The only thing I wanted to say before I let the people go who want to go, and just say I'm happy to stay around and answer questions and anything like that, is that you will receive a request for feedback for the course. As I said at the start, the feedback's really important to us. We love hearing both the positive feedback and the negative feedback, because that's what helps us get better at this. So please take, even if it's just 5 minutes of your time, to fill in the feedback form. And we're not asking for war and peace for a big essay on this. Even if you can only think of one bullet point, positive and negative, that's great. If you've got more to contribute, that's awesome. But please take the time to fill out the feedback, because it's really useful to us, and it's how it really helps us improve these things and make them better. And obviously, if you liked it, there's lots of other ARCHER2 courses out there in the future. You're welcome to come and join us again, and hopefully we'll see you at some of those in the future. So thank you for your attention. I'm happy to stick around and answer questions. I know some people might need to head off, and if you do need to head off, that's great. If you think of any questions afterwards, just get in touch with the service desk, and they can always point the questions at me anyway, because they know I've been running this course. And yeah, I hope you get on and find something useful to do with ARCHER2 and found the course useful. So Camilla asked if this material is going to stay online. Yes, it will. For as long as GitHub pages let it stay up there, it will stay up there, the course material, and it'll be linked from the ARCHER2 website in the past materials repository. And Naman asks, is it good practice to compile projects on the login nodes? So yes, I mean, unless the source code is really, really large and you're blowing your quote on the login nodes, and you're blowing your quote, sorry, I'm talking about home file system. Yes, compiling on the login nodes is fine. The only challenge you might find is something that takes absolutely hours to compile. So there's a particular program called OpenFOAM in CFD that can take 12 to 13 hours to build. Then you might end up be better writing a job script to compile it once you've done some tests on the login node, so you know what the commands look like. And then submit a job, because you don't want to have to sit at your terminal, keep your terminal open for 13 hours to try and compile a piece of software.